Hey guys, this video is going to teach you how to read and interpret and find the equation of sine and cosine graphs. So we're sticking with sine and cosine because, as you remember from the other day, tangent has a lot of areas that are undefined. So tangent is not really practical for real life situations, but sine and cosine do have a lot of real life applications. Sine and cosine are periodic and they make that wave pattern. So sound waves, phases of the moon, high tide and low tide, average temperatures, hours of daylight throughout the year, things that kind of average out to be highs and lows over the course of time, you can model with sine and cosine. So the difference between the graphs of sine and cosine. Sine should go through the midline. So I obviously I don't have very perfect drawing skills, but you should have an equal amount of space above this middle line as you have below. Same thing with cosine. This distance should be the same as this distance. So I am going to talk about this equation over here, but the midline is a part of the equation. Now this is the parent function, so everything is at 0, 0. So this is the midline. So we can shift that midline up or down, just like we shifted other graphs up and down, but sine should have, it should go through the midline, like right on the y-axis. Cosine starts at the maximum. So the y-axis is really how you tell the difference between sine and cosine. All right, so I want to refer back to those 4 points that are on the x-axis and the y-axis that we use to figure out sine and cosine. All of those answers that you were getting for the sine of 30, the sine of 45, the sine of 60, the sine of 150, all of those answers are actually values on this graph. If you graph this in Desmos and you pull up a table, you're going to see a lot of irrational numbers because it's numbers like the square root of 3 over 2, the square root of 1 over 2. So if you remember, I'm starting with sine first. If you remember, the sine is the y-coordinates of the ordered pair. And it goes 0, 90, this is 180, and 270. So you see those are the same numbers that I have along my x-axis. Now keep in mind those could be in radians. I'm putting them in the degrees just so it's easier. So at 0, my sine is 0. At 90 degrees, my sine is 1. At 180 degrees, it's 0. 270 degrees, my sine is -1. And then 360 is back to 0. All right, and the same thing for cosine. Cosine is the x-coordinate of the ordered pair. So when the degree is 0, cosine is 1. So you see cosine starts at the maximum. And then at 90 degrees, cosine is 0. At 180 degrees, cosine is -1. At 270 degrees, cosine is 0. And then 360, it's back where it started. All right, so those numbers are coming from the same answers that we just did when we evaluated sine, cosine, and tangent would be the same, but we're not doing tangent. All right, so the amplitude is kind of like the maximum or the minimum of the graph, but the amplitude is always a positive number, and it's referring to the distance from the midline to the maximum or the minimum. It should be the same because midline is in the middle. So for the parent function, the amplitude is just 1 because that's as high as it goes. It only goes up to 1 on the parent function. In the equation, the amplitude is always the number before you see sine or cosine. That tells you the amplitude of the graph. Now, so if the question says like find the amplitude, you're supposed to give a positive answer because amplitude represents distance. However, there could be a negative in front, and that would be a transformation. The amplitude would still be a positive number, but if you see a negative in front, then that means your graph has been reflected over the x-axis. All right, but the amplitude is the number out front, but it's also going to tell you from the midline to the maximum or the minimum. It tells you where to plot those maximum and minimum points. All right, probably the trickiest one is the b value and how that relates to the graph. So these are periodic. Typically, it goes up to 360. That's the parent function, 1 full cycle. Every full cycle is called a period. So with a sine wave, you're looking for this wave specifically. Sine starts at the middle, it goes up, down, back to the middle. That's 1 full cycle. With cosine, it goes up, down, up. That's 1 full cycle of cosine. So the period is however many degrees it takes for that wave to show up. On the parent function, it's 360, which 360 is also equal to 2 pi. So a lot of the times you're going to see the radian numbers along the x-axis, but feel free, you can convert them to degrees if you want to. So the B number that's here helps you find the period. The B number is not equal to anything, but we have to use that number to help us figure out the period. Figure out the length of that cycle, how many degrees it's going to take to make that wave. So we do that by 2 pi over b. So whatever that number is, 2 pi over b. If you wanted to use 360 instead, you could, but if you see pi in the problem, it might be better off to use that 2 pi over b. All right, so let's do some examples. I'm gonna only have time for 1 or 2. So let's do 3 sine 2x plus 1. Now you're not going to have to produce these graphs yourself, but you are going to have to match an equation to a graph, so I'm just going to sketch the graph out. So I typically only draw the positive half of the graph, but you could draw the negative half as well. It doesn't matter. So here's my normal graph. Here's my x-axis. When I'm graphing these, the first thing that I do is look at my midline. So I can tell this plus 1 is going to shift my graph up 1. All right, the next thing that I'm going to do, I always do a little sketch off to the side of what my wave is supposed to look like. So sine is supposed to look like this. So now I have a picture in my head of what sine is supposed to look like. So I know I could put a point right there because that's supposed to be where sine starts on the midline. All right, the other thing that I do next is I look at the amplitude. The amplitude tells me that my maximum is going to be 3 above the midline. My minimum is going to be 3 below. So if I am at 1, I need to go up 3. And that's going to be where my maximum is. Down 3. That's going to be where my minimum is. So now I kind of have my graph contained. I know that that's where it's going to be like bouncing back and forth in between those 2 pink lines. All right, to figure out the period, I'll do it both ways just so you can see. I'll do it with 2 pi and I'll do it with 360. It's 2 pi over b or 360 over b, and this is b. B is the number that's inside the sine or the cosine, like with the x. So in radians, 2 pi over 2, that would be pi. In degrees, 360 divided by 2 would be 180, and those are the same thing. We should know pi is equal to 180 by now. So that means my graph is going to go up, down, and back up. And this number right here on my x-axis is 180 or pi, however you want to label it. But my amplitude was 3. My period is pi or 180, whichever you have. And my midline is at +1. All right, let's do one with cosine. Oh, and I only have a few minutes left. All right, so -2 cosine pi over x minus 3. So again, I like to start with what the cosine wave looks like, so I know what my graph is supposed to be. I start by what my midline is. So my midline is at -3. So I start with my midline. And then I look at my amplitude. So my amplitude is 2. So that means it'll be up 2 and down 2. So I know my wave is bouncing back and forth between those numbers. All right, because my b is pi, I'm going to use the 2 pi over b. So 2 pi over pi is 2. Right, it doesn't make sense to do 360 divided by pi because that's just going to be an irrational decimal. So my answer is 2. So I know cosine starts at the maximum, but this negative sign means my graph is reflected, which means it's going to look like this. It's going to be upside down. So I'm going to go from the minimum all the way up, all the way down, and because my period is 2, this number on the x-axis would be 2.